In this lesson, we are going to be solving absolute value equations. So first, let's look at this simple one here. We have the absolute value of x is equal to 4. So what number could be inside of these absolute value signs that would be equal to 4? Well, what we know about absolute value is absolute value means the distance from 0. So what numbers have the distance from 0 of 4? Well, there are two numbers. There's 4 and negative 4. We could say the absolute value of 4 is equal to 4, or the absolute value of negative 4 is also equal to 4. Notice that there's two possible solutions. So when we're solving our equations today, we're going to notice that there are two possible solutions because of the absolute value signs. So let's look here. Here's an example of an equation. The first thing you want to do when solving absolute value equations is always to isolate the absolute value on one side of the equation by itself. So when I look up here on the left side of the equation, I have the absolute value, what's inside of it here, but it's not by itself. There is also being multiplied by a 4 on the same side. So before I do anything else, I have to get the absolute value of x plus 2 by itself. Since it's being multiplied by 4, to move that 4 to the other side, I would divide both sides by 4, because what I would do to one side of the equation, I have to do to both sides. The 4 divided by 4 is 1. That goes away. We are left with the absolute value of x plus 2 on one side. And on the right side, we have 24 divided by 4, which is 6. Now that we have the absolute value by itself, remember on the previous slide that we said what? We had this, oh, sorry, that was an x. We had this set up on the previous slide. This number inside could have been 4 or negative 4 because both of those have the absolute value of 4. So what we're going to do now is we're going to set up two equations. Inside of here, this could equal 6, or it could all equal negative 6. So we're going to set up both equations. What you do now is you're going to drop the absolute value sign, and you're going to just write the equation like it says. What is on this side is equal to 6. But since it's the absolute value, what is on that side can also be equal to negative 6. So let's look to see what we did here. We set up two equations. The first equation looks, here's my little eyes, looks just like this one. In the second equation, you set it up the same way, but it's equal to the opposite. Now you solve both equations. On both equations, we need to subtract 2 on both sides. So it could be 4. And if you subtract 2 over here, the answer could be negative 8. Now let's plug these back into the original equation and see if both of these would check out. Okay, go back up here to the beginning. We think one of the solutions is 4. So if we plug in 4 right here, 4 plus 2 is 6. The absolute value of 6 is 6. Then we multiply it times 4, and that does equal 24. So that checks. What happens when we plug in the negative 8? Does that check out? Negative 8 plus 2 is negative 6, but the absolute value of negative 6 is 6. So again, we have 6 times 4 equals 24. So both of those numbers check out. So there are two solutions. So we're going to be setting up two equations with two solutions. Here's a review of what we just saw. Setting up our two equations. And there's the solutions. Okay, so let's try this again. Remember, first our goal is to get the absolute value by itself. Well, we look on the left side, we have the absolute value with nothing with it, so it's already by itself on the left side of the equation. Our next step is to set up two equations. First of all, the first equation looks just like that one, but you drop the absolute value sign. For the second equation, you set it up the same way. The absolute value, or what's inside the absolute value, does not change, but we set it equal to the opposite. So it could be 8 or negative 8. Now we solve both sides, so we add 2.5 to both sides, and that would be x is equal to 10.5, or 10 and 5/10. We add 2.5 to both sides over here, We have different signs, so that would be negative 5.5. So we have two possible solutions again. So let's plug those back in and see if they work. If we go back and we plug in 10 and 5/10 minus 2 and 5/10, that would be 8. And the absolute value of 8 is 8, so that checks. On this side, if we were to plug in negative 5 and 5/10 minus, sorry, I forgot my minus sign there, minus 2 and 5/10, that would be a negative 8, but we want the absolute value of that, and that is 8, which is equal to 8. So they both check out. So you're setting up two equations. One looks just like the original, and the other one you set it up using equal to the opposite of what it was. Okay, so let's look at another example. There's your two equations. Okay, on this one, on the left side of the equation, the absolute value is not by itself. We have to get it by itself first. It's being added to 3. So the first thing we're going to do is move the 3 to the other side of the equation. So now we have the absolute value of x minus 1 is equal to 0. Well, what's the opposite of 0? The opposite of 0 is 0. So when setting up our two equations here, our first equation looks just like that. You drop the absolute value signs. But in setting up the second equation, there is no opposite to 0. So then this particular one, there's only going to be one solution. It's possible to just be one solution when it's equal to 0. So we're saying x is equal to 1. Let's plug that back in. 1 minus 1 is 0, and 3 plus 0 is equal to 3, so it checks. So this one only had one solution because you can't do the opposite of 0 to set up the second equation. So here's a reminder, when the absolute value is equal to 0, there will only be one solution because you cannot do the opposite of 0. Okay, here's another example. We have the absolute value of negative 2x plus 3 on the left side of the equation. It is by itself, so we're ready to set up our two equations. The first equation looks just like that one, except you drop the absolute value signs. In the second equation, what's inside the absolute value sign stays the same, and we set it equal to the opposite, which would be a negative 5 and 8/10. Now we have two-step equations, so we're going to solve. First, we subtract 3 on both sides, so we have negative 2x is equal to 2 and 8/10. Divide both sides by negative 2, and we have x is equal to negative 1 and 4/10. On this side, we subtract 3 on both sides, and we have negative 2x is equal to negative 8 and 8/10. And when you divide both sides by negative 2, x is equal to a positive 4 and 4/10. Two possible solutions. I'm working through them. Now, to make sure, you would always have to plug those back in to see if they both check, to see if they are indeed solutions. Here's another example. First step, again, is to isolate the absolute value on one side of the equation by itself. So we're going to subtract 7 on both sides. Now, what do we have the absolute value equal to here? It is equal to 0. So this is one of those that you will only have one solution. So your equation is 3x plus 9 is equal, plus 9, my head was already doing the math there, is equal to 0. We subtract 9 on both sides. You have 3x is equal to negative 9. Divide by 3, and we think that x is equal to negative 3. Let's plug that back in and see if it checks. 3 times negative 3 is a negative 9, and a negative 9 plus 9 is 0. So the absolute value of 0 is 0. So 7 is equal to 7. It does check. In this example, the absolute value is not by itself on the left side, so we have to get it by itself by adding 6 to both sides first. Then we have the absolute value of x minus 3 is equal to 8. We can set up our two equations. The first one looks exactly like that one without the absolute value signs. The second one, the absolute value stays the same, but we set it equal to the opposite. We have two equations that we have to add 3 to both sides on both of them. So x is equal to 11 and x is equal to negative 5. So let's check these and see if they would check out. If we put 11 in for 3, 11 minus 3 is 8, and the absolute value of 8 is 8, and 8 minus 6 is 2, so that one checks. If we plug in a negative 5 minus 3 would be a negative 8, and the absolute value of negative 8 is 8, and 8 minus 6 is 2. So that one also indeed does check out. And this one gets a little bit longer. Notice that on the same side with the absolute value, it is being multiplied by 4 and added to 2. So which one do we move to the other side first? We move remember PEMDAS? When we're using inverse operations, we always start here and get rid of the addition or subtraction first. So that means we're going to get rid of the plus 2 first by subtracting 2 on both sides of the equation. So we're going to subtract 2 on both sides. Now we have 4 times the absolute value of 3 minus 2x on the left side. And on the right side we have 0. The absolute value is being multiplied by 4. So now we have to divide both sides by 4. And we know that 0 divided by 4 is 0. Since this is set equal to 0, we can't do the opposite of 0, so we only have one equation. So we drop the absolute value sign and solve. First, by moving the 3 to the other side. Negative 2x is equal to negative 3. Divide by negative 2. That's supposed to be negative 3. So it would be a positive 1.5. Erase all this up here so that you can see that coming up on the PowerPoint slides there. Same thing that I wrote. So 3/2 would be your solution. Okay, another example. We have the absolute value is not by itself. We have to move the 10 to the other side first by subtracting 10 on both sides. So we have the absolute value of x plus 2 is equal to negative 17. We're ready to set up our two equations. The first one looks just like it, dropping the absolute value signs. The second, the absolute value stays the same, but we set it equal to the opposite, which is a positive 17. Now we do this subtract 2 on both sides to see what our solutions would be. And we see that x would be equal to negative 19 and 15. So let's go back and check and see if they work out. If we plug in a negative 15, or negative 19 plus a positive 2 is negative 17, and the absolute value of negative 17 is a positive 17, and 17 plus 10 equals 27. That one does not check out. Let's check the 15. If we plug in the 15 up there, 15 plus 2 is 17, and 17 plus 10 is 27. That one does not check out. So what we've discovered here, when we check them, is that since they don't check out, there is no solution. No solution because they do not check out. What that means is that the absolute value can never be negative. If you look up here, see how absolute value right here was set equal to a negative number. You need to watch for this because I want you to think about this for a minute. I'm going to erase all this so you can see all that. When you're asking what is the absolute value of a number, the absolute value of a number is always positive. So the number on this side has to be a positive number. Because that was negative, there is no way that there can be a solution. So if you know this, when you get to this point right here and you see that absolute value set equal to a negative number, you should just know that there's no solution without having to find the solutions. Plug it back in to see if they check. So be watching for that. So after you get the absolute value by itself on one side, check to make sure that the other side is positive. If not, there is no solution. So let's look at this one. First, we have to subtract 3 on both sides. That gets the absolute value by itself. Okay, we have it equal to a positive number, so we know that there's going to be a solution. We set up both equations. The first one looks just like it. The second one is set equal to the opposite. We subtract 5 on both sides. Divide by -8, and we'd see that x is equal to 1/2. Here we subtract 5 on both sides. -8x is equal to -6. Divide by -8. I'm working through these two-step equations pretty quickly because I feel like you guys know how to do that pretty well. 3 fourths, sorry, I had to think for a second. So we think the solution is 1/2 and 3/4. So there's all my PowerPoint on top of my scribbling. We could plug those back in and they would be the solutions. But remember, when I got to this step right here, and I got that absolute value by itself, make sure that this side is a positive number or there is no solution. Okay, on this one first, we're going to have to subtract 8 on both sides of the equation first. So we have -2 times the absolute value of x plus 5 is equal to -6. Now we divide by sides both -2. Remember, our goal is to get the absolute value by itself. When we do that, we get a positive 3. Okay, that's a positive. The absolute value is set equal to a positive number. So we know that there's going to be a solution. Whoops. I thought the PowerPoint was going to work it out. And then when you work it out, it would be -8 and -2. So I hope that these examples have helped you with solving absolute value equations.